The fuel system of the JCB Diesel Max consists of the following. The fuel, coming from the tank, enters the chassis-mounted 5-micron filter water separator lift pump. It then goes through a 2-micron fuel filter. The filtered fuel passes through the transfer pump located inside the high-pressure fuel pump. There are two elements within the pump casing: the transfer pump and the high-pressure pump. Fuel enters the transfer pump from the 2-micron fuel filter at approximately 0.7 to 1 bar. As the vanes within the transfer pump rotate, the fuel is forced into a diminishing space and is pressurized to approximately 5 bar, where it then enters the inlet valve of the high-pressure pump. As the camshaft rotates within the pump, springs keep the pistons in contact with the cam profile. As the piston is displaced by the cam, fuel enters the pump via the fuel inlet valve. As the cam continues to rotate, the piston pressurizes the fuel in the inlet chamber. The inlet valve closes and pressure begins to build. Once the pressure has reached the outlet pressure, the outlet valve opens and the fuel is released into the common rail. At this point, the fuel has achieved a pressure of up to 1200 bar. As the pressure within the pump decays, the outlet valve closes, fuel is drawn into the inlet chamber, and the cycle begins again. Fuel is forced under extremely high pressure, up to 1200 bar, from the fuel pump via a single fuel pipe to the fuel rail, and from the rail to the individual fuel injectors. The injector solenoids are energized. Fuel is released into the cylinder and combustion takes place. Leak-off fuel from the injectors and pump is returned to the tank. The electronic control unit collects information from a number of sensors throughout the engine. It uses this information to maintain pressure and to calculate the exact moment at which the injector releases fuel into the cylinder for optimum combustion. This signal is sent directly from the electronic control unit to the injector solenoid. It must be borne in mind at all times that a pressure of 1200 bar exists within the fuel system, pressure similar to commercial water jet machines used to cut metal. With pressures as high as these, the need for extreme care in working on components of the system and the importance of the non-contamination of fuel within the system is vital.